we are going to analyze. Like I said, every single chapter. Okay, we're going to analyze this log graph. Now, before we do that, let's kind of look at the parent function. What's the parent function here? Log x. So, log x looks like this. Now, remember I said it goes all the way down, even though your graphing calculator is not going to show you that. What's the transformation on this log graph? 2 to the right. Okay. Now go ahead and graph and analyze. Okay, Alana, domain. Not all real numbers. We don't have any numbers on the left of something. Very close. Greater than 0 would be the original graph, but we moved 2 to the right. Yes, greater than 2. So 2 to infinity. Trey, range. Andy, continuity. Continuous. Josh, increasing. 2 to infinity? Yes. Evan, decreasing. Sorry, Ashley, boundedness. Unbounded. McKenna, extrema? No. Caleb, symmetry. No. Mark, asymptote. X equals 2, yes. And behavior, limit as x goes to infinity, f of x goes to infinity. Limit as x goes to not negative infinity, it never goes to negative infinity, it goes to 2. F of x goes to negative infinity. Let's analyze the inverse function. How do I find the inverse? First step. Switch x and y. Next, how do I get rid of that log? Running out of time. Gotta raise by 10. Now we cancel that log. So 10 to the x is equal to y minus 2. And then we add 2. All right, we're going to finish this tomorrow. Okay, so this is where we left off yesterday. We said we were going to analyze that inverse function of the original function. So we got to this point where that is the inverse function. So now what I want you to do is graph it on your graphing calculator and analyze that function. Remember that inverse function has a relationship with the original function, right? So first of all, domain and range switches, right? And it is reflected over y equals x, so you can almost think about how it's going to increase, how it's going to decrease, where will they have a boundedness, that kind of stuff. You can almost predict it even without graphing it. That's kind of the beauty of knowing that they are inverse of each other. So go ahead and analyze. If you need, you can graph it and look at it. If you don't need it, you can probably just imagine how it's going to look like. Hey, let's start with Amelia. What is the domain of this 10 to the x plus 2? Let me kind of show you. This graph is going to look like this. Yes, all real numbers. Sally, what is the range? No, it's definitely not all real numbers. Yes, y is greater than 2 or 2 to infinity. Aaron, what's the continuity? Jennifer, increasing? Yes, so all real numbers. Penny, decreasing? Yeah, no decreasing, none. Iris, boundedness. It is not unbounded. Sherry, what do you think?
Bounded below.
Yes, bounded below. So there is a horizontal asymptote here. And if you kind of think about it, the original function, which was the natural log, log x minus 2 looked like this, and there was a vertical asymptote. Junior, you want to try the extrema? Is there a maximum minimum?
No.
Yeah, correct. None. Blake, symmetry.
None.
Allison, asymptote. Y equals 2. Eunice, you have the hard one. And behavior. F of x equals?
Infinity.
Yes.
And then fx2.
Yes, good.
Okay, cool.
Okay, any questions? So how you analyze the original function, in this case, was just log. Find the inverse function and then analyze the inverse function, knowing that they have a lot of similarities because they're inverse of each other. Yes?
Wait, so for the end behavior, do you look at the range or the mean?
You look at both actually, because you're asking yourself, when x is going in this direction, where is y going to? When x is going in this direction, where is y going to? That's kind of what end behavior means.
Okay, so how would you get 2?
When x is going to negative infinity, y is going to go to 2. It's not going to go down. Below
it's
2.
Okay.
Yeah. Okay, the last thing we're going to do today is just review on transformation for logs. This is very, very easy. So again, we have our general equation for all kinds of functions. A times, in this case, our parent function is log, so it's just going to be log. And it could be any kind of base, so let's just say base b. And we have a x minus h, and this time we have over c because we have a horizontal stretch or compress. And then outside of the function, we have a plus k. The base b does nothing to the function, okay? That's just the parent function. So for example, number 1, what is the parent function? Natural log. Okay, so then what does the plus 2 do? Left 2. Yes. Okay, very easy. I think I need to make the questions harder next year. All of them only has one transformation, so too easy. Okay, number 2 is probably the hardest one out of all of them. First of all, what is the parent function? Natural log again. This is not in the right order, so I'm going to kind of change it so it's negative x plus 3. And we talked about this. We said if there is any kind of number next to x, we have to factor it out, right? So we want to change that to a negative times x minus 3. So now if you look at it, what are the transformations? Okay, right, 3. Yes, reflect y-axis because the negative is inside. So again, please make sure you factor out whatever is in front of x. All right, the last 2 are so easy. One transformation only. All right, number 3, Alana, what is the transformation? Yes, good. And then last one, Trey.
Up 1.
Yes.